Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy, Subject Code 22626, Unit 3rd, Electric Drives and Elevators. So now we will see load equalization. So the different types of loads are studied in the previous section. So in many industry application, the load varies between maximum and the minimum limits for different interval of the time. So here is the curve plotted between the load and time. It is seen that average load on motor is less even though we have to select motor rating as per the maximum load. So the maximum load is there for short interval of time. After that, the motor is on no load. A flywheel is connected to the motor shaft. The motor rotates the flywheel along with the load. During no load period, the flywheel accelerates and stores energy, and during loading period, the flywheel gives out its kinetic energy to the load. Thus, there is less load on the motor now. The motor of less rating than the maximum load can be selected because flywheel also shares the load. During no load period, the flywheel accelerates and stores the mechanical energy. During the loading, the flywheel supplies power to the load, and it is seen that the speed fluctuations are less than the flywheel is connected. So this is the method of the load equalization. So the best way to do this is to increase the moment of the inertia of motor by flywheel. So the process of smoothing out the fluctuations in the load is known as the load equalization. And in industrial drives, the load varies between very wide limits in a very short intervals of the times. Example, steel rolling mill, in which the load is very large during the rolling operation and very little when charges pass by. A typical example is as shown in the figure. So during the period when load is small, flywheel accelerates and stores the kinetic energy. Thus demand on supply side remains constant, and when the load increases during the peak period, flywheel gives a part of its kinetic energy, thus keeping in decreasing the demand on the supply side. It is thus practical to have a motor whose torque is not as large as the required load torque, the gap being adjusted by the flywheel. These are the conditions for the load equalization. So there, in load equalization process, the fluctuations in the load are to be smoothened. Flywheel is used to this purpose. So the fluctuations may occur due to the two conditions, that is load increasing and load decreasing. So we will see one by one. So when the load is increasing condition, when the load on the motor increases, the flywheel decelerates and give up some part of kinetic energy to the load, and here the notations are TL equal to load torque, TM equal to motor torque, TE equal to no load torque, TF equal to flywheel torque, J equal to moment of inertia of the flywheel, G is the gravitational constant, K is the slip speed in radian per second per Tm. When load on motor increases, the flywheel deaccelerates and gives up a part of its kinetic energy to the load. The torque to be supplied by motor is given by Tm equal to TL minus Tf. The Fw torque is to be evaluated in terms of its moment of inertia and drop in the speed. The energy stored by the flywheel at any speed omega is given by half into j by 2 omega square. For this condition, load increasing, the speed drops from omega naught no load speed to omega. The kinetic energy is given up by j by 2 omega naught square minus omega square equal to the j by 2. Again put the value omega naught minus omega divided by omega minus omega. So by substituting we get the j by 2 omega naught plus omega into s. The derivation part is not covered due to the scope of the syllabus. So only final expressions for the load increasing condition is Tm equal to TL minus E minus T raised to J by K, then TL minus T0 when torque is in Newton meter, and Tm equal to TL minus E raised to minus Tg divided by Jk, TL minus T0 when torque is in kg per meter. So our next case is the load decreasing. So when load on the motor decreases, Fw accelerates and stores the energy, that is flywheel. The torque to be supplied by the motor is given by Tm equal to T0 plus Tf, and the Tf value is J into ds by dt. The final expression is Tm equal to T0 minus e raised to minus t into jk by jk, T0 minus Tm, where Tm dash equal to torque at the instant when load is removed. Useful conversions, that is torque conversion is Newton meter is converted into kg meter by dividing by 9.81, and similarly we have to convert from kg meter to Newton meter. We have to multiply it by 9.81. That is, while converting the torque from Newton meter to kg meter, it should be divided by 9.81, and while converting torque with the kg into meter to Newton meter, it should be multiplied by 9.81. So similarly there are the speed conversion, that is, while speed is to be converted from rpm to radian per second, it should be multiplied by 2 by 60, and if speed is to be converted from radian per second to rpm, it should be divided by 2 by 60. Then our next topic is the braking. So what mean by electric braking? Electric braking when the running motor is to be stopped. Either mechanical brakes are applied, otherwise the motor can be stopped electrically. First and at the last, mechanical brakes are applied. Electrical braking is the braking where kinetic energy of motor and tool is converted into electric energy, and finally it is dissipated into the heat energy, or the part of the energy is returned to the supply, regenerative. Electric braking does not bring the motor to the standstill but bring the motor to the low speed, and mechanical brakes are applied. So the requirements of the ideal braking system is that simple, convenient and comfortable, then effective, less wear and tear of the braking assembly, less heat generation, and the quick response. Advantages and disadvantages of electrical braking over the mechanical braking system are: it is more reliable braking system because in mechanical braking heat is produced at brake block and brake shoes, which may be source of the failure of the brake. In electrical braking dynamic, heat is produced at the convenient place, external rheostat, which is not harmful to the braking system. So the braking actuation time is small as higher value of braking retardation is obtained. Electrical braking is smooth and gradual, whereas if the mechanical brakes are not correctly adjusted, then there are the chances of the sudden braking, which is discomfortable to the passenger. Life of the braking system is more because mechanical braking provides metal dust due to the friction. No such dust is formed in electrical braking. There is less wear and tear of the brake shoes, brake block, so there is less maintenance cost. Higher speeds are possible even when train is going down the gradient. As braking system is reliable, trains having heavy loads can be stopped even when train going up the gradient. Higher speeds of train is possible as braking system is reliable, so payload capacity increases. In case of electric regenerative braking, we can utilize 60 to 80% of kinetic energy to generate electricity, which is not possible with the mechanical braking. Here is the types of electrical braking system. First is the plugging, that is reverse current braking, rheostatic braking, dynamic braking, and the regenerative braking. So first is the plugging. In this method, the connections of motor are changed or reversed such that motor tends to rotate in opposite direction and thus braking action is achieved. Plugging with the DC motor. The plugging for the DC shunt motor and the series motor are shown in the diagram. So in the normal operation, the armature is connected with the shunt with the field winding and the voltage is applied. So in the plugging operation, we have inserted a resistor, variable resistor in series with the armature winding. So this is the plugging with the DC shunt motor and plugging with the DC series motor. In this case, the field winding and the armature winding are connected in series with each other, and plugging operation in which armature is connected in series with the field winding and in series the variable resistor is inserted. So next is the rheostatic braking, that is dynamic braking. In rheostatic braking, the motor is disconnected from the supply and its kinetic energy sets converted to the electric energy generator action. This electrical energy is supplied to a rheostat connected across the motor terminals. Thus, kinetic energy is dissipated in the form of heat in the resistance and braking is obtained. Thank you.